Hi, my name is Adrian Alvarado and I'm a student from Concorde Career College. Today we'll be doing laboratory number 23, experiment 2 from the chemistry class. The instructor is Dr. Atala. Today's date, December 6, 2020. Let's go ahead and start. The materials for this experiment will be 100 millimeter and 10 millimeter graduated cylinders, a permanent marker, 25 millimeters of cola, the substance from the last experiment, which is sodium acetate, 25 millimeters of acetic acid, 3 beakers, the scale, pH meter, weight boat, borax, 4 pipettes, and this the water. For the first part, we're gonna be doing the buffering setup. We're gonna use a graduated cylinder. Graduated cylinder, and we're gonna pour and measure 10 millimeters of acetic acid into the 100 millimeter beaker. So let's go ahead and pour. Well, I already have it here. So let's just pour 10 millimeters. Let's see. A little bit too much. Perfect. So now let's pour it in the beaker. There it is. And using a graduated cylinder to measure and pour 10 millimeters of sodium acetate into the same 100 millimeter beaker to create 20 millimeter solution. So we're gonna get rid of this. And we're gonna bring 10 millimeters of sodium acetate. We don't need this pipette, so let's get rid of it. Let's see. 10 millimeters and make this one 20 millimeters. Steps. 20 millimeters. F. It's the pH meter with 10 millimeters of distilled water. H. So that's 10 and another 10. Now let's measure the pH of beaker H. And this is what I got. Well, it turned off, but I got 3.4. Using a pipette, we're gonna measure 5 millimeters of cola into beaker F. So we have beaker F and the cola. Let's measure 5 millimeters. This is 2 millimeters and a half. And another 2 millimeters and a half. Now we're gonna use a clean 10 millimeter graduated cylinder to pour an additional 10 millimeters of cola into beaker F. The solution should now have 20 millimeters of cola. They should have said in the beginning just to pour 2 of these, but okay. Now we're gonna use the pH meter to determine the pH and record the measurements on table 4. So let's go ahead and use the pH meter. And we get, and again it turned off, we get 3.88 approximately. Now we're gonna use beaker H and pipette 5 millimeters of cola into the beaker. So once again, let's pipette 5 millimeters of cola. It's important to have exact measurements because the experiment will work better. So be careful on your measurements. So for beaker H, we're gonna swirl the solution and meter and determine the pH recorded in table 4. Then we will discard the solution on beaker F and beaker H. Make sure to rinse these two with running water and let them dry with paper towels. Just dry them really well. Thank you. So we're gonna start with part number 2, which is pH of solutions. And the first step, we're gonna measure and pour 20 milliliters of water into a new clean beaker and label it as beaker I. So let's go ahead and pour 20 milliliters of water into the new beaker. So this is 10. Now for the second step, we're gonna use our scale and measure 4 grams of borax. I already have them here. It should be 4 grams. This is labeled it as 4 grams, but it is more. So be careful. It's not 4 grams. It's 5 grams that I have in the bag. So let's use our weight boat and pour 4 grams of borax in here. As I said before, check your weights. This little baggie was labeled as 4 grams, but it's not. Instead, it was 5. I don't know if it's another gram from the bag, probably, but let's just make sure. There it is. 4.1, but it's okay. Now we're gonna use beaker J. This is the borax solution. Let's put away our weight scale. And we're gonna use the 100 millimeter beaker, graduated cylinder, to pour 100 millimeters of water into the beaker J. So 100 millimeters of water, beaker J. That should do it. That's 100 millimeters. This borax solution, which contains sodium borate, will be used to observe effects of base on the buffer in beaker G, created in part 1. Now we're gonna use the pipette to add 5 millimeters of borax solution to the buffer in beaker G. So this is the buffer on beaker G. We're gonna go ahead and swirl the solution really well, because as you guys can see, the borax is still on the bottom. So I'm gonna use this little crystal mixer and now this is a clean pipette. Let's go ahead and pour 5 millimeters, 2 millimeters and a half, and 2 millimeters and a half. That'll do it. Let's move our solutions and let's use our pH meter and it should be at 0. There it is. So now let's go ahead and take the measurements of this solution. So my measurement is 4.09. We're gonna record it in table 5. So now we're gonna pipette another 5 millimeters of borax solution on beaker G. Now we should have 10 millimeters of borax solution in beaker G. Previously we poured 5 millimeters. So now we're gonna pour another 5 to make 10 millimeters. So I'm sorry about this, but 2.5 and 2.5. Now let's use our pH meter again and measure it and put the numbers in the table. Now I got 4.23. We're gonna go ahead and add 10 more millimeters of borax solution into the beaker. I was gonna use my graduated cylinder, but I noticed that there's still borax in the bottom. So what I'm gonna do, I'm just gonna use the same pipette, mix it really well, and after there's nothing in the bottom, I'm gonna grab 2.5 millimeters. Four of this to make 10 millimeters. And just mix it really well so we could grab some of the granules in the bottom. That's the third one. And this is the last one. Okay. Now we could see there is borax accumulated on the bottom of this beaker. And we're gonna go ahead and use our pH meter and take more measurements of this solution. Before we got 4.23, if I'm not making a mistake. Now we have 4.57 on this solution. So the pH is increasing on the solution every single time that we add the borax solution. We're gonna record our measurements on table 5, and the last step will be adding borax to beaker I, which is 5 millimeters only, and measure the pH with our pH meter and record it on table 5. After we are done pouring the borax into the solution, if you can see, this is 8.29. It has a pH of 8 is going up, 8.33, 34, 35, 36 on this solution, in the beaker I. So we will observe the effects of the acidic on buffer F and H, and also the effects of the acid on buffer J and I, recorded in the table. And there you have it. It's 8.4. It was steady. We're gonna discard both of the solutions down the drain with running water. So this was my experiment. I know it was a little bit long, but hopefully you guys understood and got the measurements for the tables. And that's about it. Have a great day. My name is Adrian Alvarado. I'm a student from Concorde Career College. The class is chemistry, Dr. Atala. And have fun.